Okay, so I'll do my best to get these out as quickly as possible, but of course, whoever is the last, the back row in this case, and I'll sometimes start at the back, they'll have a disadvantage. And but do this as relatively quickly as you can. I'll give you plenty of time, but at the end, some people like to savor the experience, and so I might have to ask you to finish more quickly than you would prefer. So here you are. Here's, I don't know if that's 3. I'll give you an extra one just in case. Here's 2 for you. There, I think that's 2. 1, 2, 3, 4. Yeah, good enough. That might be 5. It's only 1. There's, I think that's 2. Yeah, that good? Yeah. All right. Does anyone need one that no one's? Okay. So I'll let you go to this. This is pretty straightforward. I think everyone's going to get 100% or maybe 95 or whatever. And I'll put it on the screen for those who are watching the video later. Oh, and I hate to interrupt you, but just so that you know, in future, if you are watching the video, what I usually do is I scroll through the quiz so that if you want to, you can pause and try it yourself. It's good practice. And then you can look at the answers. So I guess a hint for those who are watching the video. Pause the video if you need to. Okay, yeah. Oops. Well, some of you are probably already done. I got done quite a while ago. And so if you are done, you could take your quiz, turn it upside down, and send it towards the middle, and I'll come get it from whence I gave it to you. So make a little stack for me. If you're still working on this, don't panic yet. I'll let you know when it's time to panic. So take your time. Nice. Thank you. Excellent. Thank you. Wasn't too bad. Oh, oh, extra one? Yes. Interesting. Okay. All right, so now those of you who are savoring the experience should start to panic. So try to finish it up in the next minute, and then I'll collect what you have. All set? Yeah, excellent. I have math stickers that look like this. I don't want a dog sticker. I've got math. Oh yeah, or maybe the one with the sunglasses actually. All right, I'll come by and see what you have. So try to put that, circle that last problem that you're doing, and then we're going to go over the answers here in just a minute. Is it good? Yeah, you're going to make me walk. That's fine. It's okay. All right, I think I've got them all. Sometimes I have a holdout though who tries to, hang on to theirs for longer than need be. But do I have all of them? Okay, because sometimes I'll be going over the quiz and someone will say, I've still got mine. Okay, well, I've got them all now. Okay, let's see what I have. Hopefully I got the right answers. If there are questions though, please do let me know, but these are pretty straightforward. If you did the homework for today, you got an A, I'm sure, 100% on this. So salaries of college graduates is ratio, of course, because we can talk about, my salary is double someone else's salary or one half or whatever it is. Hair colors of students is nominal. And then t-shirt size is ordinal. Birth years is interval. We had talked about years in the whole business with there isn't like an absolute zero. Depending on what calendar you would have different ratios. So interval for that. Gender of dogs is nominal, even though maybe you think that a particular gender is better than another. Doesn't matter. Second favorite color. Sad that our person who suggested that isn't here, but nominal. Beverage size ordinal. Number of pets is ratio. You have double how many pets I have, or an infinite. Well, don't have to talk about that. And then these down here, just to remind you, if it's something that you can count, usually that's almost always going to, well, actually always, I think. If you can count it, it is discrete. And if you are measuring it, it's almost always continuous. So things like heights, those are measurements, they're continuous. The number you're counting, 1, 2, 3, 4, 5, you're never gonna, well, I suppose you might argue you can have a 1.5 story house. I remember when I was shopping for houses 27 years ago, seeing advertisements for houses that were 1.5 stories, whatever that means. But anyway, it's not continuous is the main thing. Number of limbs, you're counting, it's 1, 2, 3, and so forth. And then temperature is continuous because it's a measurement. You could have 22, 22.1, 22.057, depending on how fine your measurement device is. Okay, good enough. Hopefully everyone got 100 or close to 100 on that. I'll give this back to you next time. A couple of functions. Why do I give you quizzes? Number one is because I want you to do your homework. And so if you do your homework, you'll do well on the quiz. Hopefully you noticed that. Secondly, I want you to have an idea of how I ask my questions on the test. So when the test comes, I take all of our quizzes and I just concatenate them. That means smash them all together into one big document, and then I edit and make your test based on the quizzes. And I might throw some other stuff in there, but largely it's just your quizzes. So you might wonder, how is my test different from the homework? Well, look at the quiz. That's going to help you. And then thirdly, next time when I hand these back, I will hopefully solidify in my mind your names. So I will be able to find Luther. Oh, there is no Luther in here. But I will be able to find each of you and give you your quiz next time. So that's that. Let's go on. What do we got today? We're doing definitions. So I find this to be a more boring stuff, but maybe you'll find it exciting. We do have to be able to speak the same language. So I guess that it's good to go over these definitions for that reason. Let's see, this is annoying me there. Okay, so there's I think 4 definitions that we're really going to focus on, though. And when we get to them, I'll make sure that I emphasize them. So this is just a bunch of definitions, but there's 4 that are really important. And those are the 4 that you're going to definitely have on your quiz next time. I'll warn you when we get there. So for now, though, let's just get to the basic definitions. This is just the definition of what statistics is. And by the way, once again, since I wouldn't suggest writing every single word down. Some of you are different than me, though, um, and you prefer to write every single word down. So I try to limit the number of words on my slides for that reason. However, if you miss something, you can always go to the video and later and pause, and you can find every single word there, and it'll be there for you. But anyway, statistics is just the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. Statistics, this subject that we're learning, is divided into two main topics, two main groups of things. One of them is the collecting, organizing of the data, and the other is the analyzing and interpreting of the data. So those are the two main groupings, and we have names for those two groupings. The first one, the collecting and organizing, you probably have learned about this back in middle school and high school and maybe even elementary school. Anyone who went to elementary school and made a chart with rotini about people's favorite colors, gluing the pasta to a piece of construction paper. You know what I'm talking about. My daughters all brought home this stuff, and I had to throw it away. But anyway, this is basically descriptive statistics. You're just making graphs. So organizing and summarizing the data, that is descriptive statistics. Probably something you've done. We won't spend a lot of time on this. I always end up spending more time than I want to on this topic, because the good stuff, though, is the second half of this, and that is the inferential statistics. Inferential statistics are the formal methods for drawing conclusions based on your good data. So if you have data, and you probably recognize this is just a scatter plot, and you want to draw a conclusion about whatever these variables are, that would be inferential statistics. How good is our data? Now, in order to make these inferences, we're going to have to deal with some probability, because every statement in statistics that is inferential will always have probability behind it, whether it's actually explicitly stated or not. Anytime you see statistics in the news, there is probability lurking somewhere back there. So the statistics is based on the theory of probability. So you can think of games of chance such as poker, or you could think of roulette, gambling games. I will have, when we get to the probability section, we will talk about gambling. I'm opposed to gambling. I'll explain why when we get there. But those are nice, easy descriptions. Like, can we predict what will happen in the future based on what has happened in the past? You can get an idea for this using games of chance. But when we make predictions, they generally, will take the form of a probability. I'll say that I am this % sure that I'm correct. I'll never say I'm 100% sure. We never prove anything with statistics. Statistics does not prove. Statistics just lends evidence. It's like we're in a court of law and we say, the evidence, the preponderance of the evidence is that this person is guilty of murder. That's what we're trying to do, is we're trying to build evidence for our case, and that's what statistics does. It's never 100% sure. So we can never be 100% sure that the person did the crime. Well, I don't know, maybe you can. But anyway, so here's some questions that we might be able to use statistics for. Is the likelihood of an earthquake, likelihood of rain, which is 0 today because it's going to snow rather than rain, or whether you will get an A in this course. Can we make a prediction? And I can actually, after the first exam, I can actually predict your likelihood of getting an A in this course based on your first exam. And this is based on previous students' results. That's not to say that it's a done deal. I mean, statistics gives you evidence. It's not telling you what is 100% sure going to happen. So just bear that in mind, especially if you do poorly on the first exam. I've had people do poorly on the first exam and still get A's. Okay, so now for the 4 things that are the ones that are going to definitely be on the homework and on the quiz. So these 4 definitions. Number 1, population. So we have what we're interested in. Whenever we're doing statistics, we're going to be studying something. So I'm interested in students at MVNU. So that might be my population. It's a collection of people, things, objects that we're studying. So populations, they don't have to be people. They could be objects. I might be interested in the classrooms. I have a colleague, a person I work with who is very interested, very invested in classroom space because he is in charge of making sure that the classrooms have the stuff we need to make sure that you can be successful. And so he's got a spreadsheet with every classroom on campus and what is in that classroom. So he's in charge of making sure that people get the classroom that they need to make sure that you're successful. And so he knows this is my favorite classroom, which is why I'm here. But nonetheless, he has this spreadsheet. And so for him, his population is classrooms. Classrooms are the things that he's interested in. You might be interested in cars on campus or vehicles. And this reminds me of this survey that I have not yet sent out because I was negligent yesterday. Well, I had some things come up that I had to deal with. It will come out by Friday. Don't worry. We need to gather this data so that we can have fun in here. And you'll get a quiz grade. You get 100% for just doing it. But anyway, so cars. Some of you are interested in the color of cars or the type of vehicle people drive. That could be your population, the vehicles on campus. So what is it that we're studying? Population. We're going to practice this in a minute. Second thing. Oh, sorry. Before we do the second thing, here's an example. Determine the population. What is it that I'm interested in here? Let me read this. And this we're going to have over and over again. So I wouldn't write it down. I've got it multiple times. This slide will appear. We want to know the average amount of money first-year college students spend at MVNU on school supplies that do not include books. So I'm going to randomly survey 100 first-year students at this college, and 3 of those students, here's 3 of them, but that's just an example of the numbers that I'm getting. So I want to know, what is the population? What am I interested in here? What's the population? So maybe you could take just a minute, take a guess, and tell it to the person next to you. What do you think the population is? I'll give you a minute to communicate that. Now, there's lots of stuff on this screen, right? You have first-year college students, you have school supplies, you have money. But the thing one way to identify who I'm interested in is think about who I'm going to gather my information. I'm going to go to the first-year college students. And so that's the population here. Population for this particular study are first-year college students. I'll just put a box around that. That is the population. Who is it? Who am I interested in? I'm interested in first-year college students. Now, I will ask them about their school supplies, but it's the college students that I'm getting the information from. Okay, so now you might have said something else, but those other things might be on the next slide. So let's find out. So the next thing to talk about is the sample. The sample is the portion or the subset of a population that you're actually observing. So who is it that we actually get our information from? So we might be interested in all first-year college students, but we can't ask everyone because that takes too much time. Imagine trying to figure out what people prefer in terms, like any survey of American adults. We're not going to ask 200 million American adults a question. We will ask a sample, a small group, because it's just more cost effective and time sensitive and so forth. So you have a population, maybe something like this, population with all these people or things, and then you have a sample. So there might be a lot of people in the population that aren't in the sample, but there are a few people who are in the sample. So you have something like this, an image in your mind maybe of sample comes out of the population. Now, one of the results of this is that when we talk about population and sample, we're talking about the same thing. So let's take a look at this again. Now that you get the gist of what's going on, now I want to know the sample. I have no fear in just picking someone. And anyway, I have to do attendance, so bear with me. Go ahead and figure out what the sample is and tell it to your neighbor. And meanwhile, I will take attendance so that I can pick random people. Hold on a sec. Oh, excellent. Submit. All right, let's do this. So randomize here, and we'll figure it out. Trinity knows. Trinity, who do I actually observe for this particular um, thing? Yeah, 100 students. That's who I actually observe. So notice this, that here, just to give you sort of this idea, is that the population is all first years students, and the sample is 100 first year students. So in other words, if my population is students, my sample will be students as well. They will always be the same kind of thing. I've had people in the past on the test, they'll say that the population is homeowners and the sample is dogs. Now, the problem that you'll see on the test or the quiz next time, it has to do with dogs and homeowners, but you're never going to have, you've got this population of homeowners. None of those homeowners happen to be dogs. Well, I suppose one of them might be if some rich person leaves their house to their dog. But generally, that's not going to be the case. So make sure that the population and the sample look the same. It's the sample comes out of the population. Very nice. Okay, next. So parameter. A parameter is just a number that is a property of a population. Now, for our class, the parameters that we're going to be interested in are the following. Either you're going to be interested in means, which some of you will call average. And when we get to Microsoft Excel, that's what you're going to get, is you're going to get average in Excel, because Bill Gates doesn't know proper terminology. So that's means, or it will be a proportion or a percentage. Now, here's the thing, is that if you're dealing with quantitative data, then you're going to be computing means. Whoops, quantitative. And if you're, whatever. And if you're doing qualitative data, apparently I can't write and speak at the same time, you're going to be doing proportions. So it's just like, I don't know if you remember the slide on Monday that had like, why do we care about quantitative versus qualitative? And it's because when you're doing qualitative data, you're going to be computing proportions. This is like eye color. What is the percentage of students in this class who have brown eyes? Eye color is qualitative. We're going to be doing percentages, proportions. Quantitative, something like your age. What is the average age of students in this classroom? So when we talk about parameters, it's the number we're interested in from the population, and it will be either a mean or it'll be a proportion. So let's go over here and see if you can figure out what, oh, it's kind of obvious, but it's okay. What is the parameter for this particular problem? So here, someone's going to be joyous at being chosen. Joshua, do you know what the parameter is for this particular? The amount of money? So let me just go back. Use one of those two words. The red here, one of these words. The mean amount of money, very good. So we're interested in the mean or the average amount of money. In fact, it's right here, I guess, in this first sentence, the mean or average amount of money that first-year college students spend on school supplies. So to be precise, you would have to say it's the mean amount of money first-year students spend on school supplies. We want to be really precise. It's not the mean amount of money they spend on pizzas. It is not the mean amount of money they spend on clothing. It is the mean amount of money, although clothing could be interpreted as school supplies, but it's the school supplies. So I guess that I should highlight this whole statement. That is the parameter. Parameter is that whole thing. Okay, now you know how I said back here that the, wait, where is it? Right there. Yeah, this is, I guess this is back here. Population and sample, they always look alike. Same thing goes for parameter and the next thing that we're going to do. So if you can figure out your parameter, the statistic is also what can be pretty easy. So we actually have this word statistic that means it's a number that represents a property of the sample, and it will be same. So whoops, oh, why? Well, I guess I'm gonna stuck doing this. Just a minute. What did I just do? Sorry about this. Okay. Same as the parameter. So if you have a parameter, the parameter is the mean amount of money spent by all college students, first-year college students. For the statistic, we're interested in just the sample. And so bear with me here. Whoops, where did it go? Determine the variable. I want to know, oh, the statistic, here it is. So give me a sec here. As I write these down, it's going to be a little bit tedious. Parameter is the mean amount of money for all first years, whatever. I've run out of room, but technically I would prefer it if you write the whole thing down, the mean amount of money for all first year students that they spend on school supplies, something like that. And then the statistic is the mean amount of money spent on school supplies for the 100 first year students. So that the parameter refers to the population, everyone. The statistic refers to the sample, just the people. So in my mind, the way I think of this is you have this nice, easy way to remember is you have P for parameter, S for statistic, and then once you get that straightened out, parameter is population, and statistic comes from a sample. So however you want to remember this, I think it's convenient that they begin with the same letter, parameter, population, statistic, sample. Okay, one more thing, I guess, is variable. It's not quite, it's these four, parameter, population, statistic, sample. Those are the things that if we can get our hands on those and understand them, they're going to make doing the inferential statistics a lot easier later on. So let's talk about variables though. Variables, we're going to use letters to represent variables. You know the drill. This is not algebra class, but it is similar. You're using a variable to represent an unknown number. So this is going to represent a characteristic of interest for each person or thing in a population. So for example, back with our the problem about the school supplies, the amount of money, the variable is the actual amount of money that each student spends on school supplies. So let's see, I'll just jot this down here. Whoops, not there, right here. So the variable is the amount of money spent on school supplies. One way you can think of this is if I'm gathering data, I have to go ask questions, I have to go measure something. And so I might say, walk around and I'll say, how much did you spend on school supplies? How much did you spend? How much did you spend? So it's the thing that you're asking each of your people in your sample. That's what the variable is. So I feel like if you've got your hands on the sample, the statistic, the population parameter, that stuff tells you most of what you need to know, that this is pretty easy once you have those four. Nonetheless, I have a few examples for you to discuss with your neighbor and try to come up with the answers for. So each one of these you're going to have to come up with, based on a little vignette or scenario, come up with the population, the sample, the parameter, the statistic, and what is the variable we're measuring. And it's okay to get these wrong. In fact, I encourage you to get it wrong. Because if you get it wrong, you learn, right? That's when you learn. That's why I say bomb a few quizzes. If you got this quiz wrong, it's okay because it's worth almost nothing. But anyway, yeah, now's the time to make mistakes. So here's my example. First example, I've got several of these. So the first one, I'll read it over and then you can write down what you think each of these is. Working with a friend, college dean interested in learning about the average number of articles her faculty have published in the last year. To do so, she randomly calls 10 faculty members and asks them how many articles they published within the last year. So I want to know population, sample, parameter, statistic, and variable. Take a minute, list those off. Even if you've written nothing else down, you can put a piece on a scrap of paper, put those 5 things, and tell them to your friend and see if you have the same thing as them. If you don't, figure out why. Wow, you're also talkative this morning. Well, that's okay. We'll talk as a big group, all right? So let's go ahead and see how we did. Kaylin, what do you think of the population? Who is this dean interested in? So the faculty, yeah. So the population, we could be, whoops, just a sec. So faculty at this school. Whoa, what happened? What happened? Go back. There we go. This school. I'll just do it that way. But yeah, so try to be as specific as possible. Abby W., what about the sample? Who does this dean actually observe? Very nice, 10 faculty. Hey, good job. So yeah, if this was the quiz question next time, so far, 100%. Let's see if we can get the parameter. Caleb, what do you think the parameter is for this thing? So I'm going to use the word number because I prefer using that for things like this. But yes, the number of articles. Okay, almost. I'm leaving a couple of blanks. Number of articles. What kind of articles are we talking about? Published. Okay, very good. Published. Published by faculty. How about that? And Caleb, I'll let you off the hook after you answer one more question for me, and that is, whoops, where is it? Almost. Where is that? There it is. Which of these 2 words should I use? The mean, very good, because we're talking about a number, aren't we? And so we're going to do the mean or average. I don't care if you want to use either of those. So I'll do the mean number of articles published by faculty. So when I grade this quiz, if you just tell me number of articles, you're going to get it wrong. I want to see mean, the mean, and then what are we measuring? Mean number of articles. If you just say mean number of articles, I'll probably be like, whatever, I'm happy you understand. Be nice though if you spell it out. Of course, I realize that the more words you write, the more words I have to read. So I like conciseness. Anyway, getting back to this, let's see if we can get the statistic now. Oh, let me just do one more thing. Let me put this extra word in here. So if you don't mind, Caleb, put all. Yeah, because it's all faculty. Parameter refers to the population. All right, Joshua, what about the statistic? What's the statistic that we're going to be interested in? Wait, what happened to my stuff here? Oh, there it is. Very good. So average or in, just so that it matches, you can use average, totally fine. But I'm going to use mean. So mean number of articles published by the 10 faculty that were in the sample. Very nice. Now, finally, the variable. Oz, what's the variable? What is it that we're asking these faculty? Number of articles. Yeah, so number of articles published. I guess specifically during the past year, but let's move on. I'm getting sick of writing. All right, we have 2 more of these to look at, and then we get to change gears, which is exciting. So let's get rid of this, clear that, good. Okay, marriage counselor, interested in the proportion of clients she counsels that stay married. Define the following terms of the study, give examples where appropriate. So take a minute and see if you can answer these, come up with a population, a sample, and so forth. And feel free to whisper, because I know you don't want to talk loud, but whisper to your neighbor and see if you can come up with something if you're not sure. All right, let's see how we're doing. Alec, what do you think the population is for this study? Was it? The clients, yeah. So this, in particular, it's this marriage counselor's clients. So the people that she counsels or she. So population is this, or how about this? Clients of this marriage counselor. Oh, come on. Sorry. Marriage counselor. Okay, whatever. Okay, let's get a sample. Abby Larkin, what do you think the sample is? Okay, not quite, but I like everything until they stayed married. So let's see. The clients she counseled who so here the problem with this one is that it doesn't really explicitly tell us what the sample is, does it? Unlike this one back here, we're told that this dean actually talks to 10 faculty members. So we're left up to our own imagination to come up with a sample that would make sense. So these are clients, they came from the population, and so we could say who maybe she just talked to, I guess, who she chooses. I don't know. Yeah, we're gonna have to deal with how she chooses. Hopefully we'll get to that. But she's gonna choose some. You could say, I don't know, you could invent a sample. So I know this is frustrating that I didn't give you a sample here, but you could make one up. Maybe she just picks her most recent 20 clients or something like that. You can make up something though, since it's not given to you. Okay, parameter. Let's get this. Now that we got that out of the way, that's the one that's the worst one. Sorry, Abby, for making you do that one. But Carson, what do you think the parameter is here? Nice. Proportion of all clients who stay married. Very nice. And notice that we're referring to the population, all clients. We have proportion. So we've got everything we need here. Thank you. Good job. Next one, the statistic. So Biella, what is the statistic for this thing? Nice. The proportion of the sampled, I'll just do this, sampled clients, because I'm getting lazy here. Yeah, so there it is. Now the variable. This is the tough one for this, because anyway, we think of variables as numbers, but in this case, this is not a number. Anna, do you have any ideas as to what you would call the variable in this case? Yeah, so it has to do with, yeah, do they stay together? So remember that the variable is the thing that I'm going to go around and ask each person, how much did you spend on books? How much did you spend on supplies? That sort of thing. In this case, oh, we're on to a different thing. We'll get back to it. I'm asking, did you stay married? Did you stay married? Did you stay? So it has to do with this. Did you stay married? Yes or no? And so that is the variable. It's actually a yes or no question. So did they stay married? Or I could even do it this way. Let's make it super simple, because I'm happy for you to just, as long as you recognize that this is a yes, no question, you do this. How about this? Married, yes or no? We could just do that. So that's the variable. That's what varies between each of the couples. Does this couple stay married? Does that one, does that one, does that one? So that's what is varying. Okay, I think that given the time, I want to skip the toys. Sorry, it's very similar to the married situation. We're just looking for defective toys instead of defective marriages. But let's move on to the, here we go, how we get our sample. Okay, so I want to get, so we're, in each of these cases, we need a sample. How do we pick the sample? And so there are a bunch of different ways that you can go about getting your sample. Some are better than others. And hopefully we'll have time for the other thing I wanted to do. If not, we'll do it Friday. Gathering information about an entire population is way too expensive, way too time consuming. Imagine trying to ask everyone in the United States their opinion about the president-elect, let's just say. So to do that would take too much time, too much money. And so what newspapers and other sources of news do is they take a sample of people and they ask that sample, and then they infer something about the population based on that sample. How do they get their sample? That's what we want to talk about here. How do you get a good sample? So there are various ways of going about this. And the very best way, so we'll start with the best and then we'll go down from there, I guess. The very best way to get a sample is to do what's called simple random sampling. Simple random sampling is the act of just choosing people out of a hat, putting everyone's name in this vase and then picking, 10 people if I had you, or using a computer, that sort of a thing. That's typically how it's done these days, is that everyone is given a number. In fact, later on, we will possibly, it depends on how things go with these projects. There's a project where in the past I've randomized everyone. I just use I use Excel to come up with random numbers, and everyone gets a random number. So that's the best way. And this way, everyone has the same chance of being in the sample. So that's technically not exactly the right definition for a simple random sample, but it works. So if you think of simple random sample, everyone has the same chance of being in the sample. That's the way it should be. So that's the ideal way for picking a sample. That's difficult to do sometimes. And so this is why sometimes people do different things than this. Now, one thing that often gets done, and this is also really good, is what's called a stratified sample. And this is usually if you want to compare two groups. And so this is really just taking two simple random samples. So there's nothing wrong with this. Divide the population into groups and then you sample each of them. So for example, I might want to compare males to females. I might want to compare freshmen, sophomores, juniors. So I would want to come up with a sample of each of those groups. So that's what a stratified sample is. I'll show you examples of each of these momentarily. I have pictures. The next one is, sorry, can't read my own screen there. That's better. So the next one is called a cluster sample. Okay, so, and I've got these summarized. Do I have them summarized? Sure. I have them summarized on a slide. So I'll give you the key words here. Uh, groups, proportionate number from each there. So that's the important stuff there. You're taking a proportionate number from each group. So maybe half men, half women. Cluster sample. To get a cluster sample, you divide the population into clusters, and then you randomly select some clusters. This often gets confused with the stratified sample, but here's what cluster sampling is. We do this here at MVNU, is we divide, for example, the freshmen are in these Discipleship of the Christian Mind classes, and we might select 5 sections of Discipleship of the Christian Mind to do something with, have them do some survey. And so that's a cluster sample because it's just those 5 sections. We give the survey to everyone in those 5 sections. So that's what a cluster sample is you have these clusters. So divide the population into clusters. There it is. And then randomly select some of the clusters. That's really all that you need to know about that. It's like clusters of grapes or whatever. A systematic sample. So this, now we get into some things that aren't as good. So these, well, cluster sampling isn't all that great either because, well, for a variety of reasons we don't have to go into. Systematic sampling. This is where you take some starting point. Let's say that I start, well, with the first person, and I count you off, and I take every 10th person. So we'll take you, 2, 3, 4, 5, 6, 7, 8, 9, 10. Take you, 1, 2, or well, 2, 3, 4, 5, and so on. So if you do that, that's a systematic sample. So I'll have a picture of this in just a minute. Systematic sample. It's not as good as the other sampling techniques. These are getting worse and worse. And then finally, the worst way to get a sample is the way that most people do. And that's called a convenience sample. So convenience sample, this is just pick people that are convenient. The easy, this is when, okay, so when a student has, back in the old days, I used to make students collect data. They would say in their write-up, I walked around the cafeteria and randomly selected 10 people. Now, those people are not randomly selected. They're walking around and they're like, oh, I'll take you, I'll take you. It's not random because if you look at, oh, you look like you're not having a good day, I won't even approach you. So these aren't random at all. Actually, whenever I've seen that, I usually think this, random. So anyway, so here, let's get the summary here. So convenience sampling, this is the lazy way of doing it. Oh, I should show you a picture. Here's a picture of convenience sampling. Convenience sampling, you just use people that are easy to get to. By the way, website, when you see like a survey on a website or Facebook or Instagram, those surveys are totally convenience samples. You're just taking the people that are around. You're lazy. So, hey, do you believe in the death penalty? This guy's walking his dog. Okay, so that's convenience sample. Systematic sampling. This is every 10th person or every 5th person, that sort of thing. Let me show you a picture of this. Here's systematic sampling. We start here, 1, 2, 3, 1, 2, 3, 1, 2, 3. We take every 3rd person or whatever. So that's what you should think of when you think of systematic sampling. Cluster sampling, put people into groups. Grab, how about this? Grab entire groups. So like you're at a dinner party and the host has taken the grapes and put them into little clusters, you know, like they cut them off of the little branches. So you get a cluster of 3 or 4, and then another, maybe you don't go to dinner parties. But anyway, these clusters of grapes, that's what I think of is you grab that cluster and that cluster and that cluster. So here's what that looks like. Do I have that? Oh, here. This is actually used by the Department of Labor Statistics to do their jobs report every, because what they do is they'll take the precincts for a particular area and they'll send an interviewer into a precinct, interview everyone here. It's cost effective and it's reasonably good. They do a good job, but that's what this is. You take those 3, they interview everyone in there, and then the next time they'll take 3 different ones. What do you think, Hayden? Well, you are randomly selecting the cluster, but then yeah, and then you go into there and you interview everyone in that group. So it is random, and so that's why the labor report uses this. It's pretty good. It's not as good as simple random. Simple random sampling would pick everyone randomly. You'd have people from every precinct, which is more difficult, more costly. So anyway, last one, and then we got a stratified sampling. Stratified sampling. This is you want some sort of proportional representation. Proportional representation. In other words, if your population is half female, half males, then you would like half female, half male in your sample. Maybe you'd break it up into racial groups and you say, I want this much of each of these groups, and so on. So that's what stratified is. Here's a picture of stratified. I've got the guys and the girls, and I'm going to pick 3 guys and 3 girls. Not much of a sample, especially the population isn't all that big, but I'm just doing the best I can with my pictures. Yes, Hayden? Okay, that's yeah. Okay, you could, yeah. If that helps you imagine this, you're taking one person from each district. That's fine too. But really, we're sampling in this case. Okay, so just to warn you, yeah, I want to do this last thing that I've been waiting for in the last 5 minutes, but I want to just warn you that on your homework, you're going to be given scenarios. For example, I've got a bunch of them here, and you're going to be asked to connect them, like say, what kind of sampling method is this? For example, Kyle walking around and asking people he sees what they think about the new bike racks. That's a convenience sample. So that's pretty straightforward. Anyway, that's the sort of thing that you're going to have to do for your homework, is just connect up Kyle with the type of sampling, getting a list of students from the registrar and using a computer to randomly select. That's going to be that. So when you get to, then by the way, that's the way your quiz is going to look next time as well. What I wanted to do though with the last 5 minutes is, so I don't think you're going to have a lot of trouble. This is not hard stuff. But I want to just show you project 1. Project 1 is due next week. So under projects, we have project 1. Where is it? Oh, you don't see that. That's not project 1. There it is. Number 1, choose your data set. Oh, hidden from students. Just a minute. That should not be hidden from students. This should be shown. Okay, so I have a video of me in my basement doing this, but I wanted to show you what this looks like right now so that you can be thinking about it. Your job is to find 2 data sets that you think are kind of cool. So find a couple of data sets, and then now watch closely at what I do. After you have found your data sets, let's just find a data set here for you. Let's say that you're into football. So football data set. Oh wait, is this American or European? We'll go with American football data set. So I'm going to search for an American football data set. Ooh, StatsBomb, American football open data. Let's check it out. Let's see what this looks like. Data? Come on, show it to me. Uh-oh, this looks confusing. I don't know. What I'm looking for is something, maybe I should make this more specific. Download CSV. Usually you'll find them as comma separated value files or Excel files. Let me check this one. Is that OSU? Pro Football Reference? No. I want to be able to download this. Let me back up. I thought this would be quick. Let me check one more place. I should have had one in mind. Ooh. Okay, this is soccer. Ooh, I downloaded it. Let's see, what does it look like? All-time rating by, okay, this might be good. Rankings, players. Let me just look at what these look like. Ignore this. There. Oh, this is no good. Okay, this is no good because, okay, the reason being, your job is to find a data set. I should have had one that I could have just pointed you to. Regular season statistics. Wait, Michael Jordan, this might be good. Let me check this one. Yeah, bear with me for just a sec. Okay, let me pull this up. Oh, this is beautiful. Yeah, this is what I'm looking for. Pull it over here. Look at this, how nice this is. Okay, so you're looking for something like this. And wait, where is it? Where'd it go? There it is. And this. So you're looking for something like this that has at least 100 observations. Notice that this has well over 100 observations. And embedded in that those observations, you have both quantitative, so I see quantities here, quantitative variables, and in this case we have years, days, age. I don't know what all of these mean. I don't know what this diff is, but there's lots of quantities, and you also have qualitative variables. The opponent is a qualitative variable. There's probably other qualitative variables. So look at that, that's beautiful. So I like that one, the basketball data set, Michael Jordan. So let me copy this. So once you find your data set, you're going to do this twice. You need to do 2 of these. You're going to go back to here and you're going to check to see if someone else has already selected that data set. Notice that there are only 2 data sets on my list here. There's clean burning wood stove grants and bike sales data. Well, the Michael Jordan data hasn't been selected yet. Now you cannot edit this, so don't ask me to let you have access to this spreadsheet. I'm not going to let you. That's just so you can look to see what other people have done. And then, so it behooves you to do this early. Once you have selected your data set, made sure that no one else has it, then click here and say, okay, what is the URL? And then the name. So the name of my data set is this. And then the URL is this up here. There, it's where you go on the internet to get it. So there it is. So I'm not going to submit this just in case you all want to use this for yours. Someone else, maybe right after class, is going to go grab Michael Jordan and use that for theirs. But you need to do this twice. So this will be half of your score, and then do it again. Find a different data set, and then upload, or just tell me what it is. The reason why I'm going to make you do it twice is because oftentimes people pick bad data sets. So I'll look at these and I'll tell you that's no good. Don't use that one, the other one, because you're going to be stuck with this all semester. So pick 2 of them, and if both of them are bad, I'll give you one of mine. Okay, so that's all you have to do is find something. This will be due next week, though. Make sure it has 2 quantitative, 2 qualitative variables. We're done. Sorry I kept you a couple minutes late. Have a nice day.